Welcome back. When we presented with new time series forecasting problem, there are many things to consider, and a choice that we make will directly impact each step of our project. So we need a plan. I'd like to share with you Jason Brownlee's framework that could help us build our time series forecasting problem. So we need a structured way of thinking about our forecasting problem. A framework will help us uncover characteristic of a given time series forecasting problem. And we also have a series of specific questions that will also help us define our forecasting problem. Let's look at this framework closely, which will include different types of input and output, structured, unstructured data, regression, classification, etc. So let's dive in. First question to consider is, what are our input and what is our output? It sounds easy, but it's very important. Our prediction problem is using past observation to predict or forecast one or more possible future observation. So the input data is not the data that we'll necessarily use to train our model. Input is the historical data provided to the model in order to make our forecast. For example, last 7 days of sales to forecast next day of sales data. And output is prediction, right, or forecast for future time steps that goes beyond a data provided as input. Input can be further divided into the relationship. Input can be further divided into different types of relationship with other variables. The question is, what are the endogenous and exogenous variables? And why is it important? So endogenous variables are influenced by other variables, while exogenous are variables that are not influenced by other variables. Typically, a time series forecasting problems has endogenous variables, right? We have the output is a function of some numbers prior time steps, right? It's correlated. It may or may not have exogenous variables. The third question is, are the time series variables unstructured or structured? So we can think of series with no pattern, no obvious systematic time-dependent patterns as unstructured. And alternatively, a time series with obvious systematic patterns, for example, trend or seasonality, is our structured time series. So we can often simplify our modeling by removing those structured patterns from our data. Next, we need to consider what type of predictive modeling fits our needs, whether it's regression or classification. And of course, there is some flexibility between these different types. But in general, if we need to forecast a quantity, a numeric value such as price or volume, we would use regression. If we need to predict a category, which a label with just a small set of categories or labels, we'll need to use classification. And of course, there's a different models that can be applied to regression, and similarly different models that can be also performed for your classification problem. What type of time series you're working on? Is it univariate or is it multivariate? So if you measure one variable over time, it's univariate. In contrast, if we measure multiple variables over time, we're dealing with multivariate time series. Next question is, do we require single-step or multi-step forecast? So a forecast problem that requires a prediction of the next time step is called one-step forecasting model, and one that requires prediction of more than one step is called multi-step forecasting problem. Do we require static or dynamic model that is dynamically updated? It is possible to develop model once and just use it repeatedly to make predictions. So this model would be static. But we may also receive new observations prior to make our forecast, and we can use it to create new model or update existing model. So we can think of this model as dynamic problem. Next question is, are our observations contiguous or discontiguous? So if we have observations that are uniform over time, such as hours, days, month, these are contiguous observations. In contrast, if the observation is not uniform, these are discontiguous, and it could be caused by missing or corrupt data, or it could be that we have sporadically increasing or decreasing space-time intervals. And for this type of data, notice that sometimes specific data formatting may be required.